Hello everyone. This session I will cover the problem statement based on the linear regression model given in the syllabus. Then the scikit-learn code for this linear regression model and demonstration for different regularization techniques. So as we know, linear regression techniques is a widely used statistical tool to establish the relationship model between the two variables. In the simple word, you know that in this linear regression model, my straight line represents my model, right? For the given data set, we find the best equation of the line, right? Means best slope of the line that will cover my all the data points given in this level. So this equation represents my linear regression model, right? So where y is the response variable, which is also called as the dependent variable, x is the predictor variable, which is called as the independent variable, and this a and b are also constant, which are called as the coefficients. Right, so these are the basic terms already we have covered in the previous session. So this relationship can be here this positive linear relationship or negative linear relationship that already we have discussed in the previous topic. So in the linear regression model, we find this baseline which is covering my all the data point, right? And my loss function we calculate here to measure the accuracy of the model. Right, so this loss function is represented by this formula 1 upon 2 summation of all these differences, difference of the expected value from the predicted value. So we take summation of all these differences of all the points in the data set. So here is the problem statement given in the syllabus, right? So what is my problem statement says here? The following table shows the results of recently conducted study on the correlation of the number of hours spent driving with the risk of developing the acute backache. Find the equation of the best line for this data. Yeah, in the problem statement itself, they are saying that find the best fit line, right, to build the model, right? So here my data set represents the relation between the number of hours spent for the driving and the risk score. So these are the values the given my data set as a numerical data set, right? So you can find here in the data set already, this is the training data set where x represents my independent variable and y is the dependent variable, right? So my data set is here the single dimensional data set. So for the 10 driving hours, right, spent hours, my risk score is 95. This risk score is given in the scale 0 to 100, right? So for the 9 driving hours, my risk score is 80. Then for 2, it is 10. For 15, it's 50, right? So if you observe here, right? So in the majority of the cases, when my driving hours are more, my risk score is more, right? But this trend is not the linear, right? So with one solution, we will discuss here how this linear regression model will work for this given problem statement which is given in the syllabus, and also we will discuss the demonstration of the same on using the Jupyter notebook in the coming session. So student, here is the equation of the line y equal to slope into x plus intercept, means x plus b. So here we need to calculate, right, slope and intercept. So as you know, the formula for the slope and intercept. So once you calculate the slope and intercept, you can put into this equation to find the value of x that we discussed in the previous session. So here is the scikit-learn code, right? So there is no need to calculate the slope and intercept of the line manually in the code. Also, there are the ready-made function is available in the scikit-learn library. So here is the scikit-learn code for the linear regression model. So here we, as usual, we need to import the library from sklearn.linear_model, right? My library name is linear_model, import linear regression. So my name of the inbuilt class is linear regression where L and R is capital. Once you have imported this library, you need to create the object of this linear regression. Before that, you need the data set. My data set is here, hours data set, right? Driving hours data set to predict the risk score, right? So here my D1 is the variable we have declared to fetch this data from this CSV file, right? So here then X and Y, we are separating this data into X and Y variable because my Python language, as per my Python language requirement. So X will have my hours spent for the driving and Y will have the risk score, where Y will represent here the target variable. Then we need to clear the object, create the object of the linear regression. So here is the code for creating the object. LR is the name of my object, right? User defined variable. Then linear regression is the class, right? So this statement will create the object of the linear regression model. Once you have created this object, you can use the feed function to build this model, right? So here for this model, we are passing X and Y, my training data sets, right? So feed function will execute, right, the algorithm to find the best line of my given data set, right? So in the equation of line, you know that we need to calculate the slope and intercept. But in the scikit-learn library, it is calculated automatically with the help of my fit function, right? So now here, once you have created the model, linear regression model, you can fetch these values of coefficient and intercept. So there is a inbuilt parameters defined under this linear regression object, that is coefficient underscore, that will return you the slope of the line. And also there is an inbuilt parameter, that is LR dot intercept underscore, which will return you the intercept of the line, right? So if you want to predict the value of, right, predict the risk score of the hours 8, that you can find with the help of also equation, right? So instead of using predict function, here we are calculating the risk score using the equation we have designed with the help of this coefficient and intercept parameter fetched using this inbuilt parameter. So here is my equation of line y equal to LR dot coefficient underscore, which will return this value. Then hours is having my query point. For this query point, I want to predict the risk score, right, plus intercept here. So here, if you print y, right, this y, also we can print here the equation in terms of equation and these variables, right? So it will return you the y value, right? So this will return you the predicted value for the hours 8. So the same implementation we will discuss in the Jupyter notebook also. So here is the another example of the population and year, right? So this is also one of the best example where my input data is a continuous numerical data, right? So for this given data of a year and respective population, you can build the model and you can give here query to predict the population. So for the next year 2005, if you want to predict the population, my model will help you to predict the value, population value, right? I hope student you are clear with this. So here in the solution, again we need to calculate what the slope and intercept using the formula. So here is the slope calculated for this example. Then here is the intercept calculated for this given example of population that we are putting into the equation of line, and my year is here 2005. So here you can calculate the population. So once you are clear with this, student, you must know what are the different metrics, right? Here is the population we calculated for the 2005 year. Once you know the solution method for linear regression, you must know what are the different error measures that we can use to measure the or calculate the accuracy of the linear regression model, right? So like your classification models, there are different techniques, confusion matrix, with the help of sensitivity, specificity, precision, recall, accuracy, you can find the accuracy of the model. Similarly here in the linear models, right, linear regression model, different metrics are used to measure the accuracy. So because my outputs are numerical continuous values, here the one of the method is the coefficient of determination, which is also called as the the R-square method. So in this R-square method, we find here the accuracy of the model by using this formula 1 minus SSC upon SST. So what is SSC here? SSC is nothing but the sum of square error that already we discussed in the previous session. So yi minus y cap, summation of all the differences of the expected and predicted value, right? That you know, and SST is nothing but the differences of a data point from its mean value, right? So this factor actually represent the error. So if this factor is minimum, because we are this error will be between 0 to 1. So if this factor is a minimum, my accuracy will be more, right? Because we are subtracting this error from the 1. So SSC to be calculated using the equation of line, that is actual minus predicted. So R square equal to 1 minus 0.088 divided by 4.71. For example, these are the values for the previous model, right? So this will give you, for example, 0.98. So because this value is closer to the 1, hence my model is good. So if my R square value is closer to the 1, my model is a good model. The performance of the model is good. So the expected value of the R square is near to the 1. So we can say that R square is nothing but the represents the accuracy of your linear regression model. R square represents the accuracy. So that's why it should be near to the 1. Then another matrix for measuring the accuracy or quality of the model is what? My mean square error. So actually this is the method to calculate the error of the model, not the accuracy. So again, inbuilt function is available in the scikit-learn library, that is sklearn.matrix mean underscore square underscore error. So this mean square error is represented by, this formula is again very simple. If you observe this formula, it is nothing but the average of all the differences, right? Average value of all the differences. And what this difference is, that is yi minus y cap, expected minus predicted value. So divided by 1 upon n, number of data points. So this will give you the average distance of all the points, differences of all the points from it, the expected values, right? So this MSC is nothing but what? SSC upon n, right? So this is the formula for calculating the error in my model, right? So here is the scikit-learn code from sklearn.matrix, import mean squared error, right? So if y true is the variable and y predicted is my another variable which is representing the predicted values of the model, and these are the expected values. So this mean squared error we actually pass here y and y cap, means y, actual y and predicted y. So this will find the differences, average of all these differences in the data points, right? So my average error is what here? 0.3, right? So my average error is what? 37%. So definitely my accuracy will be here 63%, right? If my error is 37%, my accuracy will be 63%. I hope so you are clear with this. Like this, there so other metrics that we can use to measure the accuracy of the model. So here is one more example given for the Boston data set, where my data set is a large data set which is made up of the 506 rows and 13 columns, right? So this is the inbuilt data set in the scikit-learn library. That's why we have used here the function from sklearn.dataset import load Boston, right? So you can also build the model on the higher dimensionality, right, to check the and to learn the concept of regularization. For that we will use this data set, right? So here is the score that we have calculated for the previous example, right? So here is the accuracy, we are getting 0.77%, right, using train test split method. For this Boston data set. So from sklearn.linear model import linear regression, here we are building the model for the Boston data set, right? So using trend test split method. So this using this method, we are dividing the data set into the 10% test size and 90% we are taking into the training data set, right? Then if you calculate the accuracy, here we are creating the object of linear regression, and here we are building the model, right? And here we are calculating the accuracy of the model. So we are using this simple holdout method, we are getting the accuracy of 77%. My 90% data we are taking into the training data set here. Now another method also, there is a method that is cross k-fold cross validation method, that where we form in the each iteration we consider the different combination of training and testing data sets, right, to cover all the data points in the data set to build the model, right? So again there is the inbuilt function here. There is an inbuilt function here in the scikit-learn library from sklearn.model selection import cross-val score. So here is the method scores equal to cross-val. Now we are calculating the accuracy of the same model of the Boston data set. Only my method is here cross validation score, right? So here we are using cross validation score. What parameter we need to pass to this method? First is my object of the classifier, my object of the model. My model is here linear regression model. LR is the name of my object. Then my data set, that is X and Y data set. Here X data set is nothing but the Boston dot data, and Boston dot target will represent the Y data. Then number of folds you want to iterate here for this given data set. So number of folds are 7, right? Then scoring function also you need to pass here. So my squaring function is here negative mean squared error. Because my model is a linear regression model, this is also one more method to measure the error in the model. Negative mean squared error, like your mean squared error, there is a negative mean square error, right? So if you want here R square, you can also pass R square method, right? So here this function will return you the 7 different values, 1, 2, 3, 4, 5, 6, 7, 7 different values. That these are the error calculated in 7 different folds, right, of the data set. Then if you want the average score, then you can use score dot mean, right? So this is the error, 36% error, right? Near about 37% error in my model. So my accuracy will be here actually 63%, right? I hope students you are clear with this. So if you want to use the R square coefficient of determination, R square method in the cross validation score, this is the syntax here. So first you need to import this cross-val score. Then LR is my name of the model object. Then X and Y is my data set, number of folds that you need to pass here. And scoring function is now my R2. The spelling is here R2. So this will calculate actually this accuracy, not the error, right? So because R square is the accuracy measure, right? I hope student you are clear with this. Now we can discuss the scikit-learn code for the linear regression model on the Jupyter notebook. Okay. Thank you. That we will see in the next session.